All right, welcome back to another video, and today we'll be working the January 2022 paper 2 question 5. So let's go. And it says the cumulative frequency diagram below shows information about the distance, which is measured in kilometers, that each of 120 students walk to school on a particular day. So we're looking at one day in particular. Part A of the question says how many students walk at most 1 kilometers to school on that day. So we're looking for at most. So therefore, we're looking for students that walk at most, which means that it is these students, they walk less than or equal to 1 kilometers. So what we can do is extrapolate on our graph. So from 1 kilometers, we can go up until it cuts the graph. And it cuts it at this point. We can now go across to connect with the y-axis. So your lines will be much straighter than mine. So now we need to find out what this smaller perforation in between actually measures. So if you're looking at the cumulative frequency, you'll see that 1 unit basically is corresponding to 10 students. Or in this case, so they did it 2 units. For every 2 units, you have 20 students. So therefore, this would be 30, and the smaller perforations in between would equal to 2 students. So this would be 30, 32, 34, 36. So therefore, what we're seeing is that 36 students walked at most, so that's the most that they walk, at most 1 kilometer. So 36 students walk at most 1 kilometer to school on that day. For everybody else, they walked more than 1 kilometers to school. So this 1 kilometers will represent everybody that is below the in this red dotted box that we created. So these are the students. So 36 students are represented here. Part B says using the cumulative frequency diagram, determine an estimate of the median. So what we know is that median is halfway, or it is half of our data set. So therefore, if we're looking at median, it would be a half of the total number of students. So what it would be is a half of 120, and that would give us 60 students. So we're now going to extrapolate on our graph 60 students to see what is the kilometers attached to that. So we're taking our pen or pencil rather, and we are going across. So you're going on the 60th line. Yours line should be much straighter than mine. And then when it reaches the 60, then you start going down. So once it cuts the graph, you start going down to connect with the x-axis. And this would give us our distance in kilometers for the median range. So what we know is that from our x-axis, it was labeled as every 2 centimeters equal to 0.5 units. So the smaller perforation, you can know what the smaller perforation in between is, divide that 0.5 basically by 10. So therefore, each smaller perforation in between measures 0.05. So if this is 1.5 and there are 1, 2, 3, 4, 5, 6 lines in between, that will give us 0.3. So therefore, at that point where it cuts it is 1.3. So it is 1.3. The median would be cut the line at 1.3 kilometers. So our median, just trying to write that, so our median is equal to 1.3. Now this asks us for the lower quartile range. So if you remember what the lower quartile range is, it is a quarter of the total. In this case, it will be a quarter of the 120 students. Or you can also look at it, since we know what the median is, it is halfway between the starting point and the median. So it could be a half of 60, which would give us 30, or the official formula is equal to, it would be a quarter, so it is quarter of the total, so it is quarter of 120, and when you work that out, what you'll get is 30 students. So we're now taking that 30 and extrapolate on our graph. So it will be 30 here, and we are going across until it cuts our graph. Cuts at this point, and then we start going down. So this is from 0.5, and this is 5, 6, 7, 8. So 8, 0.05, that would give us 0.4. So it is 0.4 plus 0.5, that would give us 0.9. So right here where it cuts is 0.9. So let me just get back our cursor. So that is equal to 0.9, or if you look for every 2, it is 0.1 kilometers. So this would be 0.5, then right here is 0.6, right here is 0.7, 0.8, 0.9. The same thing for here. That's how we get the 1.3. It would be 1, 1.1, 1.2, 1.3. For the interquartile range, what we need for the interquartile range is the upper quartile and the lower quartile. So the formula for interquartile range is upper quartile minus lower quartile. We don't have the upper quartile range as yet. So first we have to calculate what the upper quartile is. So the upper quartile, the upper quartile would be 3/4 of the total. So what it would be is 3/4. Let's go again. Upper quartile is equal to 3/4 of the total, which in this case is 120. So therefore, what we'll get for that upper quartile is therefore equal to 90, or it is a halfway between the median and the upper part of the data set, which in this case halfway between 60 to 120, which would be 90. So now we're doing the same thing again, extrapolating at the 90. So we're going across. And where it meets our graph, we start going down. And right here, it cuts it. And this would be 1.55, because remember, each of these was 0.05. So this would be 1.55. So our upper quartile is equal to 1.55. So therefore, now the formula for interquartile range, so interquartile range, so we're using this IQR, it would be equal to the upper quartile minus the lower quartile. And we have both those readings, so therefore interquartile range, our upper quartile is 1.55 minus our lower quartile, which is 0.9. So when you do that, therefore interquartile quartile range is equal to 0.65. And that would be the interquartile range. So just some formulas there to remember. Part C now says, a student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers to school on that day? So we're looking for students that walked more than 1.5. So we're coming here to where 1.5 is, and we are extrapolating up until it meets our graph, so where it cuts it directly. So it is right here, it overlaps, then we start going across. And this point would be 82. But remember, 82 is from the 0 up, so this is 82. So these are students that walk less than 1.5. What we're looking for is students that walk more than 1.5 kilometers. So what we'll start by doing is calculating those students. So therefore, that would be 120 minus 82. So when we do 120 minus 82, what we'll get is 38. So therefore, the probability for students that walked more than, so probability for students that walked more than more than 1.5 kilometers, it is equal to 38 over 120. So remember, that is it. You're looking for what are the students in this range expressed over the total. So the students that walk for more than 1.5 kilometers is 38 over the total number of students, which is 120. And we're always encouraged to simplify. So this would be 2 into 38 will give us 19. 2 into 120, that will give us 60. And this would be our final probability, 19 over 60. So this is the probability that the student walked more than 1.5 kilometers to school on that day. Part 5, it says complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. So remember, apart from completing, we're calculating the mean distance. So looking at completing the midpoint area, you'll realize that to calculate midpoint, you're adding both the lower range and the upper range and divide it by 2. So it is 0 plus 0.5 divided by 2 gave us 0.25. 0.5 plus 1 divided by 2 gave us 0.75. So that is the same thing that we're doing for this missing value. So therefore, the midpoint, it would be 1.5 plus 2 divided by 2. And when you do that, what you'll get is 1.75. So our midpoint, which is x, is equal to 1.75. Now we can look at the number of students for each group. So for this first range of 1.5 to 2, so we're extrapolating from 2. So let's go back to our graph. So from 2, we're going up until it cuts our graph. And then we are going across. At this point, it should be 112. But remember, this is a cumulative frequency figure, which means that everything beneath it is also a part of this 112. Therefore, to get what the individual number of students in this range group, we'll need to subtract all of these figures that are before from it. So number of students in that range, which is 1.5, is equal to, it will be 112 minus, so for the total before, it would be 46, so let's add that. The cumulative frequency before 46 plus 24 plus 12, that will give us 82. So it is 112 minus 82. So the number of students for that first missing value would be 112 minus 82, and that will give us 30 students. For the second one, in 2, where d is greater than 2 but less than or equal to 2.5, we're coming again on our graph. So it will be 2.5. We're extrapolating. Going up and right here, and we are going across. Until we cut the y-axis. That's kind of lean. So it will be right here, and that figure would be 118. Again, remember, this 118 is cumulative frequency, and what we're looking for is frequency by itself. So therefore, again, we're going to do the same thing. So therefore, number of students, so that ranges 2 less than d, d is less than or greater or equal to 2.5. So that would be, remember, the total cumulative frequency up to this point. Before it was 112 because we just calculated it right here from this extrapolation. So it is now 112. So it would be from the one that we have just now, 118 minus 112, and that will give us the frequency for this group, which we will get as 6. How will you know that your answer for these are correct? Because your total number of students, if when you add all the figures here, indeed you will get 120. So we calculated the first 3 empty slots. Now we're in the f of x portion. So the first f of x, it would be equal to, so our midpoint was 1.5, our frequency was 30, so it is 30 multiplied by 1.5, and that will give us 45 as our f of x value. No, not 1.5, 30 multiplied by 1.75, and that will give us 52.5. So it is f, which we got as 30, by the x value, which we got as 1.75, and we get 52.5 as our f of x. For the second empty slot in this part, what we'll have is f of x, it is equal to, our f value is 6 being multiplied by the x value, which they gave us as 2.25, and that will give us 13.5 as our answer. No, this is just a start of it, because what they really asked us to calculate is the mean. Now, having all this data, we can go ahead and calculate our mean. And if you remember, the formula for mean, let's see where we can do it. So our formula for mean, it is equal the sum of f of x. So let's sum of f of x divided by the sum of the frequency, or the total frequency, which in this case would be the 120 students. All right, so let's switch the position, or let me see if I can change the color to ensure that you guys are seeing it. So red. All right, yes. So therefore, the sum of f of x, so our mean, therefore, mean is equal to the sum of f of x would therefore be the 3 plus the 18 plus 57.5 plus the 2 that we calculated here, which is 52.5 plus 13.5 plus 5.5, and all of that is divided by the sum of the frequency. We already know what that is, which is 120. So therefore, our mean, when you do sum of f of x, you'll get 3 plus 80 plus 57.5 plus 52.5 plus 13.5 plus 5.5, and you get 150. So it is 150 divided by 120. And when you do that calculation, what you'll get is 1.25 kilometers as our mean. So that is our answer for our mean, 1.25 kilometers. So let me just switch out these tables. I already have that info. So this is the calculation that was there for the mean. So the mean is the sum of f of x over the sum of the frequency. So we add all our sum of f of x. We know what our sum frequency would have been, which is 120, and we get that to be 1.25 kilometers. So thank you for watching, thank you for joining, and we will see you in another video.